Well, hello, welcome back to the Tale 3 Cabins. I'm sorry that this behemoth has gotten in the way, but I want to talk about this. I was going through my emails a couple weeks ago, and I got one from Anker, wanted me to review a new product that they had coming out, and I deleted it. So then I was back on my highly advanced computer again, checking emails about 3 days later, and they sent me another one, and I was about to delete it, and then something caught my eye, and it's over here on this side of the device. And it's 240 volts output. Never seen one with 240 volts output. So I replied to him and said, yes, I would like to check this thing out because this is getting closer and closer to the ultimate home backup. A lot of other power stations, when you would talk about them, they call them home backup devices, but technically they were all 120 volt output. It was not something that you could easily plug into your grid system and power the whole house, but now things have changed. All right, so let's get into the meat and potatoes of what this is actually designed for. So I'm in my breezeway right now. Next door is the garage. In the garage I have a sump panel, and I have a receptacle for a generator to be plugged into there. You might have seen it a couple of years ago if you've watched my videos. I did have a power outage. I showed you how I use my generator to plug in and energize the rest of the house. It is not the safest way. It is definitely not code, but it's quick and dirty. So we're going to use this method first using a heavy duty plug. And I'm basically going to plug it into here. I'm going to make sure my panel is off and shut all the power off to the house. I'll plug into the 240 outlet on the side here. I will plug into my receptacle in the garage. I will turn on that breaker, energize the house. We'll get an idea of what type of wattage I'm pulling just now on an average day. And then I'm going to systematically go through the house and start turning things off that I don't need. So there's a lot of vampire type of devices just using up electricity that you don't know about. So a lot of little power bricks. If you're not using those, unplug them. TVs, use a small amount of wattage even when they're not on. So when I start backing up my house with this device, there's certain things that I want to keep going. So I want to keep my sump pump going. That's very important here. My sump pump probably runs 3 times every 2 hours, even when it's not raining. There's just a high water table here. I think there's little underground streams, and my sump pump needs to be on all the time. I also have a freezer down in the basement, so I want to keep that going. I have a regular full-size refrigerator up in the kitchen. If I want to use the microwave for some reason, I want to have that accessible. Also a toaster, coffee maker, some lights. I have a tankless water heater, so I just need electricity for the igniter. I want my internet modem and then Wi-Fi to also be running. It is wintertime here right now, so we have gas heat, so I don't think it would be an issue to use the gas furnace because all we're really going to be doing is using the blower motor. So let's get started. Okay, so my main grid power is off. We're running the house off of this power station. Right now it's pulling around 599 watts, 590 watts, somewhere in that area. I imagine that the freezer is clicked on down in the basement. It was running when I first shut it off down there. I got some lights in the garage I'm going to shut off, but I'm going to systematically go through the house now, shut off the things I know that I don't need, see what we can get this wattage down to. But the goal here is just to see how much we could drop this down, get an idea of how long this would take for the battery to deplete. Currently it's saying, I believe, almost 5 hours if we just wanted to continuously run like we are doing. And then I want to mention the way I have this hooked up is not up to code. It's quick and dirty. It's the old way I used to do it. Towards the end of this video, I'll show you a better way that's more up to code, a lot safer, and has a few more benefits to that method than what I'm doing here. So I went around and turned off all the little vampire devices. I'm down to about 210 to 215 watts, and that's probably without the refrigerators running at all or the sump pump kicking in. If this should spike up, that's probably going to be one of those devices. I still have access to the microwave, to the toaster if I want to make a cup of coffee. And it says I can get about 11 to 12 hours off of just running the house this way. So this is perfect for what I'm looking for, especially overnight. Because a lot of times in the past, if we run the generator, we have to set it outside of the garage so we don't build up carbon monoxide that could back into the house. And then it's close to our bedroom window, so it's pretty noisy. We still want to keep our sump pump going and stuff like that overnight. So this would work out perfect for overnight. If you have some solar panels, you can hook the solar panels up in the daytime. 1,000 watts would be ideal, maybe even a little better than that. But 1,000 watts would feed you that 200 watts during the daytime, plus give you 800 watts surplus to start feeding back and recharging this device So if you go 800 watts times 4 or 5 hours of good sunshine, you are looking at recharging this device and starting all over again from scratch. Now, if it's bad weather and you don't have a string of sunny days, well, then that's probably where a small generator could come in handy. You don't have to spend a lot of money on a big expensive one. You just need one that's going to output somewhere around 1800 to 2000 watts. And you could charge this thing up during the daytime and then be ready to go at night again and kind of alternate. So you're not making the noise of the generator. We wouldn't have fumes backing into our bedroom window here if it's the summertime and we have our windows open at night. All right, what I'm going to do now is I'm going to click my furnace on. Just heard the blower motor coming out outside. I'm ramping up. I got 518 watts. Okay, I'm pulling 900 watts now, so I'm assuming a few other things are on along with the furnace. I'm not sure if you can hear it or not, but the fans have clicked on a couple times since I've been doing this, and it's not too terribly loud. So if you were going to have this in a room or something like that, I don't think it would disturb you when you're sleeping. But that was a pretty good test just to kind of get a ballpark of how long this would last. I think I'm going to do another one where I start backing up the house at about 10 o'clock, 11 o'clock at night, and then we maybe watch TV for an hour or two, and then we go to bed. Okay, so I just shut off our regular power to the house. I just plugged into the power station. I turned it on. Probably both refrigerators are running. It's about 10:30 at night. We're going to probably just watch TV for a little bit and then go to bed. And we'll see how this does overnight and into the morning. So we'll see you in the morning. 7:30 a.m. and there's about 39% battery left, so it did pretty good overnight. I'm going to turn on the furnace and just see how long I can run the furnace before this thing kicks off. And just a reminder, we probably would have had a better percentage this morning if we only had one refrigerator, because we'd had two on it overnight. It's about 10:30 in the morning. We've lasted about 12 hours. The furnace did deplete pretty much the rest of the battery. I did get some notices on my phone saying that the battery was getting low. Told me one at 10%, and it said one at 5%. And it was fairly accurate all the way down to 1%, just how much time was going to be left. I think it was a pretty good example that we saved a couple hundred watts, over 200 watts of just shutting off stuff that we're not even using, probably haven't used in weeks, but they're still plugged in with little adapters. Real quick, you have the 240 volts that I mentioned, but this can put out 6,000 watts, which is basically going to run anything that you could throw at it. It has a battery capacity of 3,840 watt hours, so it's a pretty large battery. If you want to add additional batteries, you can supplement this with additional batteries that will essentially double. You'll add another 3,840 watts, and you can put up to 6 of those batteries connected to this device. Let's just talk about some of the features. So on the front, you can see that you have a nice display panel. Over here is a car adapter that has a separate on-off switch for that. Here are 3 USB-C ports, and those are 100 watts. And then you have 2 USB-A ports, and those are 12 watts. These are on continuously. There's no on-off switch for them. You have a button for the display to turn the display on and off. In the app, you can control the display depending on how long you want it to be on. You can have it on for a minute, 5 minutes. Right now, I have it set for 30 minutes. And then over here, you have your total on-off of the device. You can turn this light on here, but that is only through the app itself. On this side, this is where the goodies are. You have a 50 amp NEMA connection. So if you have an RV that has a 50 amp connection, you can plug into this. Now, one thing I want to stress is that this only puts out 6,000 watts. So this is technically not 50 amps. It is 25 amps at 240 volts. If you multiply 25 times 240, that gives you 6,000. That's your 6,000 watts of output. Next to that is the 30 amp NEMA connection, and that's the little twist lock for the plug. You have to give it a little twist once you plug it in. Those are fairly common. And then you have 6 AC regular outlets that are 2,400 watts. And these are on 2 phases. So on the left is one phase and on the right is another phase, and that's why you can get 240 out of this thing. The left side of these outlets you can use as a UPS backup, so an uninterrupted power supply. Have your computer running or certain devices that if there's power flickering off and on and you want this to continuously run the power to those devices, then you would use these 3 outlets on the left. Okay, so then on your left and my right is where the inputs are for this device. So you have your AC plug here, which would connect into the side and connect to an AC outlet. And then if you want to charge it via AC, it'll charge up to 1,800 watts and it'll charge in a little over 2 hours, about 2 hours and 20 minutes. There are also 2 solar inputs here, and you can put a maximum of 2,400 watts of solar in here. I just purchased 3 panels that are 300 watts each, so I'm going to hook up to this later. Hopefully we'll get a sunny day. Right now there's a wind advisory out and it's pretty nasty outside. If you hear some stuff hitting the roof of the pole barn, you hear some noise in the background, that's what's going on. But the solar inputs each can take 60 volts and 25 amps. And if you configure your solar panels just right, you can get 2,400 volts of solar in here. If you're charging off of AC and think you want to supplement it with a little bit of solar power, you cannot do that. The AC is going to override whatever solar you have coming in. But you can do more solar on the input side of this than you can AC if you have the panels available. Okay, on the very top there's a connection here, and that is for a new device that Anker just came out with, and it's basically a whole home solar grid tie management system that would manage if you have a lot of solar panels. Essentially what it's trying to do is take out the thought process in the solar system and make it a little bit easier, take out all the extra devices you need when you set something up, and take out a lot of the professional labor that needs to be used to install a solar system in your home. The bottom port here is for expansion, so if you're going to install an expansion battery, it nests nicely on top here. It probably sits about this tall. If you think of it, this is probably all batteries right here from this point down up, and that's basically about the same amount of space that the expansion batteries take up. As I mentioned, you can get up to 6 expansion batteries connected to this. They have a nice flexible cable that each one comes with. So if you really want to go crazy, you can buy 2 Anker SOLIX F3800s. And these can be paired together, and you can actually increase your output from 6,000 watts to 12,000. This has 6,000 watts and it'll peak at 9,000 watts. Giving you 6,000 to 12,000, that's basically running an air conditioner in your home, even if it's a large air conditioner system in your home, and anything that you could throw at it. So they're leaving a lot of room for expandability. It just depends on your needs. If you want to start out small and then with some solar panels and then start working your way up, and that's basically how they have this all set up. So I have 3 things connected that used to give some of the other power stations a little bit of trouble. So let's start out with the chop saw. Can it run a chop saw? No problem with the chop saw. Let's try the compressor. Compressor sounds decent. Let's try the chop vac. Chop vac sounds good. Let's try all 3 of them. Chop vac, compressor, chop saw. Pretty impressive. So I glanced at the wattage real quick and it was just over 3,000 watts. So we were just about at the halfway point of what this can put out. So that's pretty impressive. One thing, if you notice, I put these on both sides so they're each taking a different phase. I think if I piled this up all onto one, let me see if I could get it in there. All right, I'll try it, and I'm pretty sure I'm going to overload it because you're only supposed to go 2,400 a side, but let's see what happens. They all worked. I looked over here again, it was peaking around 3,000, so maybe it will do it. Peak startup, a little over 3,000. So this is 6,000 watts out, but it's a peak of 9,000 watts. So if you think about it, so 2,400, we'll say 3,600 probably peak on each side. So that's pretty impressive. So when you order the Anker SOLIX F3800, it'll come with a warranty card. It has a 5-year warranty. It also will come with the AC cord for charging, connections for your solar panels, that if you want to have 3 solar panels and keep the voltage of those panels under 60 volts, you could put those panels in parallel, all the negatives on one side, all the positives on another side, and then that will convert it into a parallel connection, just increasing the amperage and keeping the voltage the same on those panels. All right, so currently at the release of this video, Anker is giving a promotion out with a combo deal with their SOLIX F3800 and a manual transfer switch. And in the box, if you order their combo, you get your instructions. This is the manual transfer switch here. We'll go over how that works in a second. And then also in the box comes a 10-foot 50 amp power cord. Now you may not want to mount this in the box. You may want to extend this with some heavy gauge wire. You may want to take this connection and get yourself a weatherproof service box. Use a heavy gauge wire, run it out of here, make this your connection. Maybe you want to hook this up in a garage. Maybe you want it to be hooked up at the other end of the house. On here it's going to have a watt meter to let you know how many watts are being run through this. Most of the time everything here is going to be in the line position. So that's normally when the power is working fine. And then we have a set of breakers that correspond for the circuits that you're going to pick out. They're all labeled A, B, C, D, all the way up to J here. You can do some 220 breakers. I wouldn't recommend going over 30 amps with this particular power station. If you're going to buy two F3800s and run them together, you could go up a higher amperage if you wanted to try to run an air conditioning unit or a heat pump. But for my purposes, I'm just going to leave it no more than 30 amps. I also have another 20 amp breaker here, which I don't think I have a need for. So I think I'm going to take this out and separate these and just have two 20 amp 110 circuits. And then the rest of these will be 15 amp circuits here. Now the next thing you want to think about is how conservative do you want to be? If the power does go out, there are certain things that I want to be able to still function. So maybe I would put my refrigerator on one of these. And maybe my sump pump would go on probably the 20 amp circuit here. And then I want a few lights maybe in the bedroom, run the TV. Also we have a freezer downstairs, so I want to put a freezer on it. And then we have a gas furnace, so I could hook it up to this higher amperage here just for the blower motor. And it's not going to use that much electricity, and I can run the heat in the wintertime. Probably about 40 inches of this wire here that is coming out of it. So you want to mount this fairly close to your breaker box. And then you'll notice when you look at the wires here in some fine print, it's labeled here CCC, so that's going to correspond with this circuit right here, the C circuit. It also has the same corresponding letters on the red wires too. So essentially what's going to happen is you're going to take your breaker panel, you're going to decide which circuits you want on the breaker panel and label all these with a piece of tape or mark them with a piece of tape and a corresponding letter that's going to go along with this. So that way when you take your panel cover off, you still know what you're going to be using. And essentially what's going to happen is you're going to take the black wire that is currently on your breaker, you're going to remove that and you're going to replace it with the corresponding red wire. So if you're working on the C circuit, pick the one that's got CCC. This is going to go into your old breaker. And then your black that is in your breaker panel, that is going to get married to the black that is coming out of this transfer device. So you could hook these up with wire nuts. There's no wire nuts included with this package, or you could do a Wago adapter. I kind of think the Wago adapter a little bit easier to work with, especially if your panel has a lot of wiring in there and it's very tight quarters to work with. When you work with those Wago adapters, you want to make sure that when you place them in the panel and you're going to push them off to the side, that they don't accidentally pop open. I would recommend putting a little strip of electrician's tape around it just to make sure that those don't open. Some advantages of having a transfer switch. Number one, it's safe. It's a lot safer than the method that I was using earlier where I just place it into a 220 outlet in my garage and I have to remember to shut off the main, turn on certain breakers, turn off certain breakers. If I'm doing it, I take my time and I'm very consciously aware of what is happening with the electricity and why I'm shutting that main breaker off. But if you have kids or if you have strangers around or you have some folks that think that if the power goes out and you're not there, they know what to do, it could be catastrophe. So this is much safer in the long run. Another thing is that there is no chance of backfeeding any power into the grid system. So if somebody is out there working on power lines, your power is not going to get backfed into those lines. It's all going to be cut off here at this transfer switch. Another thing about the method I was using earlier is that it's not code. It would not fly anywhere in this country of using that method. If you've had a little bit of electrical experience, so maybe you've run a new circuit to your breaker panel and put a couple more outlets in your house. If you've done that, you could probably install this with no issues. If you feel at all leery about doing this yourself, then by all means hire an electrician. I would recommend that unless you're very good with electricity. Again, this video is for entertainment purposes. What you take on upon yourself is up to you and how comfortable you feel doing it and just how much knowledge you have in the subject. One thing that I've never seen talked about so far, and this would be the perfect instance for this F3800 and this transfer switch, is that the Anker F3800 can accept solar, up to 2400 watts of solar coming in. So to me, there's a lot of times I have some panels up on my shed. We just bought some more panels, 300 watt panels. So we're going to put together about a 1,000 watt array. And a lot of times with even my previous panels on a nice sunny day, I'm thinking all my power stations are charged and I'm kind of running the lights in here just to run the lights off of the sun. But I kind of get a little frustrated thinking, man, all that energy is going to waste because I've got nothing to hook into it. One thing I can't do here is use a grid tie inverter. And basically a grid tie inverter allows you to hook up to your solar panels in this grid tie inverter and then hook into the power in your house. And then that will get fed into your house first, and then anything excess would go back to the power company. With my current meter on the house, unless I had them come out, I had an electrician come out, and I told him I want to put a solar system in, the type of meter I have right now would still continue to run forwards, even if I was generating more electricity than we were using, because it's just not the right meter for a solar setup. In Southern Ohio, I do have a meter like that if I were to hook up a grid tie inverter or put some solar and start pumping it into our house, I can make that meter run in reverse with very little effort just because it is the right kind of meter to do that. So this is a long-winded way to say back to another feature of this is that if I do have a 1,000 watt array, I have certain circuits and it's a nice sunny day, I'm feeding solar into my F3800, well, I could come in here and just turn my sump pump on and my refrigerator in certain circuits that's going to run off of the Anker, but it's also going to be accepting solar into the Anker and become a wash when it comes to power. So take a little bit off your electric bill. Your solar panels are doing something for you rather than just sitting up there going to waste. And you don't need a special meter because it is only going to feed the circuits that you tell it to, and it won't backfeed into the power grid. So that's one feature I've not heard anybody talk about, but I think it would be a worthwhile one to look into if you have the solar panels, you have that power station, and you have a transfer switch. I wish they had something like this when we first bought our hunting cabin down in Southern Ohio. I think I could have got away with not having electric service down there, and this would have suited me just fine. At the time, I just had a water pump, some lights, a TV, and maybe a space heater here and there, but we had propane heat on the wall, so we really didn't need the space heaters if we didn't use them. And couple that with 1,000 or 1,500 watts of solar, I think I could have maintained a nice level where I would not need the electric company at all, and we could have detached from the grid altogether down there. If I would have factored in the cost of this, the solar panels, and being off the grid and comparing it to what my electric bill has been down there for the last 17 years, it would have paid for this system twice over plus solar panels. If you do have a little hideaway in the woods or in the mountains, or if you want to be off grid, that this definitely makes it simpler for you to do that. Okay, so all right, I got the Anker hooked up to the RV. I am using my 50 amp adapter to 30 amp. So I'm interested to see if I run multiple things here, like the microwave, coffee maker, and right now I got the fireplace going. So the Anker is pulling a little over 1,500 watts. I also think it's charging up my lithium battery that's in the RV. It's a 200 amp hour battery. I can't run the air conditioner because it's about 25 degrees outside, so I got the fireplace going. Okay, I don't know if you can hear me or not, but I got a hair dryer running, so I'm up to 3,000 watts on the RV, and I'm going to turn on the microwave. Showed 4,200 watts coming out of the power station, so that's good. And it tripped. All right, the heater's working on the coffee maker. Real quick, we'll turn the microwave on. $4,000 watts. Still going. Still going. And tripped. Alright. So the power station cannot handle that. None of the breakers tripped. I have tripped breakers in the past where I've made toast and tried to make coffee at the same time out of the same outlet. But this doesn't appear to be the case. So you're better off if you have a 50 amp connection on your RV, and that way you can take advantage of both phases. With the 30 amp reducer on there, it's only going to give you one phase. So you want to keep your maximum load somewhere around 3,000 watts. With this peak going up to 4,000 though for about 8 seconds, that should be enough to get your air conditioner compressor up and running. And then usually once the air conditioner is running, it pulls about 2,000 watts, so 2,100 watts, somewhere in there. So you can get the air conditioner going. If you do have a 50 amp RV that has 2 air conditioners, I have seen on some other channels and forums that you can get both of those started off of this power station. All right, so the whole time testing this, I could really only come up with 2 cons. And the first would be not being able to charge solar and with electric at the same time. And the second is if you're using the 240 volt outlets, you can't use the 110 coming in to charge the power station. So after having this a little while, that's the only 2 gripes that I found. Being 132 pounds, it's pretty heavy, but for what this thing does, you're gonna expect that. The casters work great on it. They're heavy duty. Lugging it back and forth to my pole barn was not an issue. That's gonna do it. Very long-winded. I know there was a lot of stuff that we were covering here. But this power station, the bigger and the better they get, the more things they can do. And I just wanted to show you all the different facets that it has. A few things that I didn't mention is it does have a pure sine wave. I did test that out. The capacity of it, usually when you test the capacity of a power station, it does say it's 3,840 watt hours, but when you go to use it, normally you don't get that. Draining the battery down to 0 or down to 1%. I got a capacity rating of about 88-89%. If you want to throw in that 1% that it saves for maintaining the battery, then we're talking about 90%, which is pretty good. That's pretty average for a nice power station. It does have a car charging mode. If you double click on the AC button, you'll see a small icon appear of an automobile on the screen. And if you have a 50 amp car charger and you plug that in, you don't have to worry about grounding it. It does a neutral ground when you double press that button. If you have a 110 car charger, it does not create a neutral ground for that. So like previous power stations I had, we were trying to charge our car here with the 110 cord, we'd have to put a neutral ground plug in the outlet. So if Anker has any deals or any coupon codes or anything like that going on, I will put them down in the description below, and any links that will help you out to purchase this and save a little bit of money. I think that's going to do it. I think that's just plenty. So I appreciate everybody watching. I hope you enjoy and subscribe to these videos. Click on that little bell when you want to know when a new one is coming out, and keep an eye on us. Take care, everybody.